We have seen how to analyze the stability of the fixed point 0, 0 for linear systems of two differential equations as long as its eigenvalues are both non-zero. We now see how this can be used to analyze a wide class of fixed points. We'll do this in 2 dimensions, but may consider higher dimensional examples if time permits. Suppose we have 2 autonomous equations in 2 unknowns, and this system has a fixed point x sub 0 y sub 0. We're trying to figure out what happens near the fixed point. That is, we are trying to determine its stability. We'll define the Jacobian to be a matrix of partial derivatives. You see the Jacobian if you've taken Calculus 3. So each row represents a function, and each column represents a variable. Now, these are functions, so we can evaluate them at this fixed point. Doing so now gives us a numerical matrix with eigenvalues and eigenvectors. And we're going to use the eigenvalues and eigenvectors of this new matrix to analyze the stability of this fixed point. Now, we're looking at 2 systems side by side. The original system with the fixed point we're interested in, and a linear system. We defined using the Jacobian at this fixed point. This has a fixed point at the origin. And we can find the stability of this fixed point. Suppose, for example, that the Jacobian has a positive and a negative real eigenvalue. Then the origin is a saddle. This fixed point will locally share the same behavior as the origin. It's also a saddle. Now, we must emphasize that this only gives a local behavior. Over here, knowing this is a saddle tells you what a trajectory does forever. This only tells you what happens near the fixed point. Once we get away from it, who knows what happens? Maybe it keeps going forever, just like this. Maybe there's an asymptotically stable spiral it gets caught up in. We don't know what happens. But the fixed points are often precisely the points that are interesting or important to us. So being able to say what happens near a fixed point shouldn't be underestimated. In this video, we have looked at the local stability of fixed points of nonlinear systems. We have seen how we can use the Jacobian and the information we already know about linear systems to classify fixed points. We do have conditions that need to be satisfied for this to work, which we'll discuss shortly.